Complex systems appear to not have any relationships to each other, but often they do. They propagate other systems and interact with each other in, again, what are unpredictable and yet mathematically specific ways. This is a swarm chemistry simulator, which demonstrates how chemical reactions can sometimes produce what is essentially a kind of chaotic response. The study of complex systems often produces somewhat surprising results. In 2008 and 2009, members of the International Cloud Appreciation Society announced the discovery of a new kind of cloud. The last cloud that was emitted was in 1951. And cloud formations, all kinds of weather formations, are complex systems that are explained by complex dynamic theories. What happens to the Earth when a force is raised or energy soars, we don't know, because environmental data are collected by isolated sources, making it impossible to see the whole picture. With a theory that you can't manage what you can't measure, NASA and Cisco have teamed up to develop planetary skin, a global nervous system that will integrate land, sea, air, and space-based sensors, helping the public and private sectors make decisions to prevent and adapt to climate change. The pilot prototype is due by 2010. We'll track how much carbon is held by rainforests and where. And once again, one of the principal features of the dynamics of complex systems is that in order to study them, you have to take them apart, or not take them apart, you have to deal with them as a whole. So if you're asking about something like climate change, you have to be able to somehow map and connect all of the features of that rather than just focus on, for instance, auto emissions. You can focus on auto emissions all you want, but then you got what's happening with global warming and the changes in the ice caps and the rest. It all has to come together. So scientists are studying features that way. Plenty of people's Twitter feeds appear to be connected directly to their egos, but one scientist is actually wired to his brain. In April, University of Wisconsin doctoral student Adam Wilson, working with advisor Justin Williams above, tweeted 23 characters just by thinking. He focuses attention on one flashing letter after another on a computer screen while wearing a cap, outfitted with electrodes that monitor changes in his brain activity to figure out which character he wanted. His efforts spelled out using EEG to send tweet, among other messages. Feat marks a major step forward in establishing communication for people with locked-in syndrome, which paralyzes the body except for the eyes, but leaves the mind alert. For now, though, it's slow going. With the speediest brain tweeters reportedly managing just 8 characters a minute. It's a good thing they're limited, of course, in tweets to 140. But the use of complex systems and the dynamics of them are ubiquitous in modern science. The potential uses in computing science and information technologies are enormous. And so the potentials are there in these kinds of applications. So here, for example, is a complex map of the money that was contributed to senatorial elections between 2007 and 2009 for the 110th Congress. And it looks a little bit, if you will, like an internet map because of the connections of it. But with this kind of complexity mapping, folks are able to understand where, in this case, the money comes from and where it goes. And of course, if you know anything about news or politics, either one, you know that the news and politics follows the money. And so, again, you have an example here of resolution, because at one level, it just looks sort of like an internet concept map, if you will. But of course, if you get to the right resolution, then you begin to see what those relationships are among and between individuals and the money and the corporations that come to them. Another example of how visualizing data makes a huge difference in what you can understand from it.